It's time for us to handle our exceptions. So let's talk about try catch finally. I will go ahead and write try and put all of my code within the try block. Then I will write the catch statement, and then let me just format it correctly, and then I will say exception EX. Let's go over the formatting. So first you have your reserved keyword try. Then you have the curly braces, which show you what you have in the body of try. In the body of try, we have our same code that we wrote in the previous video, which took a number from a user, converted it into an integer, and if it was not successful, then threw an exception. But we also realized that when the exception was thrown, it was an unhandled exception. So we now are going to handle our exceptions and then let the application keep running. So then after the try allows us to run a block of code, but then in its catch block, it allows us to catch any exceptions that have happened here. In this case, this might happen. We already know that. So it would be caught here, and then we can do certain things with that exception. If we had a document database or anywhere else that we want to store our exceptions, we could have logged the exception, and that is a very good practice to do that. So you can come back to it and look at where it came from and then be able to fix the problem. But in our case, we don't have that. So what I'm going to do is I'm going to simply print out the exception. So I'm going to say console, write line, and then check this out. I'm going to say there was an error, and then guess what? I can use string formatting within write line. So that's also one good thing to know. I will say EX, and then there's a property called message, which is going to be the message that we have given to our exception when we're throwing it. Now let's actually take a look at this. So we're going to run this code. If there was an exception, we're going to catch it right here and then get the message from it. But note that I'm not stopping the application at any point. And this is where I want to talk about the two ways in which we can handle exceptions. First way, we can handle the exception but still stop the application. Sometimes there are critical errors that happen, and after that we actually don't want to continue the application. That is totally acceptable as long as the exception has been handled and it was a conscious decision by the programmer. But then we can also catch exceptions at times and then continue the application. In this case, we want to continue the application. So we would have logged it if we had some type of place where we are logging exceptions. And then we're printing it out and then continuing on the application. Now let me actually do another console write line. And this is going to exemplify the rest of our application. So I'm going to say the rest of my application is still running. So now we will see that if I breakpoint here and run the application, let's pass in 10 for now. This should work. So once again, the application should be running smoothly. So it says 10. This was my input. The rest of my application is still running. Fine. But what happens if I try to break it? So I will run it and then pass in a textual data. See that? Still, I got to this line. And let me show you what has been printed out. So first, it was my input, which was invalid. Then, an exception has been caught. So there was an error. Conversion was not successful because this has been thrown. I caught that exception, but then I let my application run so it wasn't crashed. But what happens if I take out the try and catch? What happens then? Let's take a look. So I will pass in an invalid input and then see an unhandled exception. If I try to say step over, which I did previously, I can't because the application is crashed. It's in a crash state. It can't go on any longer. So if this was in real life, then the user would have to close it and reopen it up again. But when we use try catch, that actually gave us an opportunity to keep going with the application. So it's actually a lot better of a user experience. So a couple of quick notes. You see here that it says exception type. Now, we don't have to have the exception type. There are many other exception types that are being derived from this main exception type. And we'll be talking about inheritance later down the line, but there is a way in which we can also write our own types. So there's actually pre-written types that are being derived from the exception type that have to do with files not being able to handle properly, and so there are exceptions for that. There are exceptions for whenever things go out of range. For example, when we try to do our string example, when we're trying to substring from 8 to 1000, so there are exceptions for that. But in this case, we're just using the main exception type, and we're saying anything that happens, catch it right here. So that's just one good thing to know. The other note is that you see here, we have another line of code, or maybe much more if I wanted to write many other lines, after we have our try-catch block. Now, that is not very good practice because we want to have a main outer try-catch, and then within that, we can have specific try-catches. So, as I said, you can have try-catches within try-catches, but you don't want to have any code after your try-catch. Reason being is that, what if there was another exception that happened in the rest of the application? Then we would have to have another try-catch separate from this. But what we want to do is want to have this main try-catch and then have the code that we would run here in the try here. And if any exception happened within that code, we'll just catch it all in one place. So it's very good for maintenance, and it's very readable when you're looking at the code. And it's a lot larger than this. So you want to have a main try-catch, and then if anything happens, we just catch it all in one place. Now you might be asking, well, where does the finally block come into place? And that's a very good question. Finally is the very last block. And finally allows us to run any code whether there was an exception or not. So in this case, let me just format it correctly. This would do the same exact thing as before, but finally has a different meaning. Finally is there first to free up any unmanaged resources. In this case, we don't have any unmanaged resources. But for example, if we're dealing with files and then for whatever reason in our try, the file just wasn't handled properly, or the file name didn't exist, or whatever else happened, and there was an exception, then we would catch it here. But at the end, we would be able to free up any unmanaged resources. Whether the catch ran or not, so whether there was an exception or not in the try block, the finally would still run because we always want to run that piece of code. We always want to free up unmanaged resources, whether there was an exception or not. But if you need more code that has nothing to do with freeing up unmanaged resources or anything else that's supporting the try block, if there's more code that you want to write, then you want to keep it in the try. And you want to then let that code, if it fails, be caught in one place. Now, you might be asking, what if I want to catch specific exceptions? For example, let's say this was a specific exception, right? And we decide that we want to have a different error message for it. So instead of saying there was an error, we want to say there was an error with conversion. Then we can specifically catch this, right? So that we can say try, and then we can put our block of code that we want to be caught specifically within that, say catch exception ex, and then just catch that one part. Just format it again, and then you can just have your specific message. There was an error with conversion. See? It's very specific. Now, this error will be a lot general. So let's say we had other errors that were happening after the conversion. Let's say then we had to open up a file and then do something with it. If that failed, then it will be caught in this catch statement instead of being caught here. This is specifically for conversion, and it has a specific message that is for conversion. Let me go over rethrowing exceptions. This is a very important concept to understand, and it's very important to understand the best practices, because otherwise you might create very nasty bugs that are very difficult to debug. So let me go ahead and grab this section, and then I will go to my Solution Explorer, create a new class. I will call it something descriptive, and it will be string to int converter. And then I will say, let's create a method. I will have an access specifier of public, return type of int, and the name will be convert. And I will pass in a string into it, which can be any other type of string, but in this case, it's the user's input that we'll be passing in. And then I will paste the contents. So see, it requires a return because we have a return value. So I have to use the return branching statement in order to return a value. In our case, it's converted number. Now, let's actually rethrow this exception that we get from here, or if we get this, let's rethrow it instead of just printing the message out. In order to do that, I will say throw, and that's it. This will throw the exception up to the caller. Now, you can see that the EX is not used, and in this example, as I said, we don't have anywhere that we can log the exceptions, but what you want to do is you want to log it first and then rethrow your exception. So in this case, I will just leave it as it is. But this will rethrow the message that we assigned to our exception. So I will rethrow the exception to the program here, and then I can either catch it here, but as I said, I want to catch it specifically. So I will have another try catch statement here, and I will say try, and the catch, I will say exception once again, EX, and then I will print the message that we had before, which was, there was an error with conversion. But now let me actually go ahead and create, so it's string to int converter, and then I will instantiate the object, and then from that object, since it's non-static, I will use the convert method that we have just wrote. And then I will pass in the input, which is the user input. There you go. Now, this method will run, and if anything goes wrong, just right here, then it will throw an exception. But the exception will be rethrown back up to the caller. And the caller will say, okay, was there any exception that you got? And we'll say, yeah, I got an exception. It was a text input. So that was an exception. And then it will be caught right here. And only then we will print the message of that exception. Okay? So that's how you rethrow exceptions. Now, let me tell you about the best practices. What you want to do and the way you want to rethrow messages, or rather exceptions, is by using the throw keyword, just like this, or you can say throw new exception. So you can create a new exception and have a new message. You can have whatever you want. In this case, I will say new message. And then you can pass in the actual exception. So in this case, this is also a best practice. What is not a best practice is to do this. If you say throw EX. Why? Because there is something known as the stack trace on the exception. It is a property actually. And the stack trace is pretty much a history of all the calls that have happened. So if you remove the stack trace, then you remove the origin of where the problem has started. So imagine if there was another method that this has been using, and that's exactly where the exception happened, but we do this, this will remove the stack trace. And that way we won't know where the problem started. It'll say that the problem started here, but that's not true. So you always want to throw or rethrow exceptions by using the throw keyword. Or if you want to wrap it in another exception, just to add a little bit more message on top of it if you need to, then you can say new exception, have your message, and then pass in the current exception that happened or has been rethrown. In this case, it has not been rethrown from anywhere else, but that is the best practice. So please use that.